Hey guys, I'm gonna teach you how to get started with i6sim Replicator so you can get a dataset for your own AI. Um, we're gonna start by downloading i6sim. I have this GitHub file that downloads i6sim for you, so all you have to do is type in git clone and copy the link. I'm gonna put this on the description of the video. And what this is going to do is it's going to download the distribution of i6sim and it's going to create a launcher for you, so you don't have to launch it from your terminal every time. You're just going to press enter and it should be copied onto your terminal. I put it on terminal on your files. It's going to be called isec installer. You're going to go to dist and this is the application. You double click this and it's going to download it for you. But before that, you want to enable long path on your Windows device, because Windows only allows certain amount of characters on your terminal to for directories at the time. But if we allow this, there can be more. And i6sim has a lot of directories inside of each other, and it won't get downloaded. So you're gonna go to your terminal, run as administrator. You're gonna say yes, and then you just put this in. It's gonna enable long path, and long path enabled. Perfect. We can close this and then you can launch that installer. After copying all the i6sim files, it's gonna freeze like this. All you have to do is type yes or just agreeing to NVIDIA's use agreement, and then it's gonna keep going. Once it's done, you should i6sim should open for you and it should be on your computer. Well, I already have that installed, so just wait until it's done and then you can keep watching the video. Once it's installed, it's gonna be in the distribution folder that you just copied from the GitHub, and you're gonna have i6sim and i6sim launcher. If you go to i6sim launcher and again go to dist, you're gonna find this i6sim launcher, which is the application that's gonna launch it for you. You might wanna make a shortcut for your desktop so you can open it at any time. I have it right here. I'm gonna double click on this and it's gonna open this. It'll ask you what GPU you want to use. I think it's not gonna let you launch it if you don't have an RTX with GPU with ray tracing. And then you choose what template you want. For synthetic data, we're gonna use action and event data generation. We're gonna press this one, and the path to your i6sim should be on settings. But if you end up moving i6sim around, just go to settings and then choose wherever i6sim is. For me, it's in here. Select saved, and then we're gonna launch i6sim on this template. It's gonna take a second the first time you're gonna launch it because it will compile shaders for the first time. But once it's done, the next times you open it should open really quickly. Wow, it's taking really long. Alright, here it is. Well, because I already installed this beforehand and this is not the main app I used, I don't use the launcher for it. I'm gonna close this, and I'm gonna launch it from my original app. Don't save. Okay. the launcher, all it's doing is it's going to this directory and it is launching these things right here. The .pad are templates for you to do different things with AsicSim. Just so you don't have to do this every time, I created this launcher. Really beginner friendly. Alright, so we're gonna create a data set for the thing we want our AI to detect. Whatever file you want to find to detect, for example, a water bottle, Xbox controller. Usually I just go to Sketchfab and there's a lot of USD files. AsicSim takes USD files and you can just download it. Usually they're open source, free to download. I already downloaded mine and I'm gonna go ahead and open it on AsicSim. So just choose what you want your AI to detect, and I'm gonna teach you how you can get a dataset based on your file. I'm gonna open my file. Here it is, Xbox controller scene. Don't save your empty scene. I don't know why it always asks you if you want to save the empty scene. And here's my Xbox controller. It looks very realistic. This is exactly what mine looks like, so it's perfect. The first thing we're going to do is we're going to give it a class inside of AsicSim. So the app knows that this thing is an Xbox controller. We're gonna do a semantic schema editor. We're gonna go to new semantic instance and we're gonna call it class. And then on semantic label, we're gonna put whatever you want to call it. I'm gonna call it controller. Then you're gonna choose the path that you want to give that class to. Since I only have scene on my world, I'm gonna choose the whole scene, which is just the controller. And I'm gonna add entry on all selected prims. You go down here on property all the way down to geometry, and if you see this semantic labels API class label controller, then you're good. Now let's get to the data creation. For the data creation, we need to create cameras to take pictures with. We're gonna go to window and then script editor. I'm gonna put it right here so it's not in the middle of my face. And I'm gonna go to the documentation for AsicSim. In synthetic data, you can actually find a bunch of API calls to create a lot of stuff. Here you can see object-based synthetic dataset generation, scene-based synthetic data generation, data augmentation, behavioral scripts, randomization, a lot of things from here, but I'm gonna focus on just the basic, which is creating random cameras. I'm gonna go to the synthetic data recorder. It's this one right here. If you want to follow the tutorial, it's actually way better than watching videos. Copy this and then just paste it in here. Let's break this code down. Look at means what the cameras are going to be looking at. Since my whole scene is my whole world, I'm just going to do scene as what it's going to look at, which is the whole controller. And then on position distribution, what this is going to do is it's going to tell the camera where to look at, like a range of where to appear randomly on every picture. I'm going to add another tab, and I made this short script to look at the size of your object. This is just going to compute the size of what you tell it to. Prim path, again, I'm going to do the whole scene. And once I run this, it should give me the size. The size in meters is 74 meters wide 61 meters tall and 60 meters thick, which looks like the proper size of a controller. No, I'm just joking. So I want to see the controller from, if this is what that represents, I want to see it from around twice the distance. So for my script, I'm gonna distribute that distance. These three right here are the minimum, and these are the maximum distributions. So in here I'm gonna put the negatives of the same number so that it gets a 30-60 degree angle on the controller, and in here I'm gonna put the positives. For X 74, I'm gonna round it up to 75 and double it. That's gonna be 1 negative 150. For Y, that's 61, round up. That's 62. I'm gonna do negative 124. And then for the third one, 60, I'm gonna round up to 61, and it's negative 122. And then the same number is just in positive over here. 150. It's 1050. Negative 124. No, positive. Then over here, 122. Now once we create this, we're gonna run this and it'll create a camera. If you see something like this, it means it worked. We're gonna go to stage, and this new folder is what it was created. It's called Replicator. Inside you're gonna have the code of the camera. If you want to mess with it or look at it, you can open the graph, and Isaac Sim, what you can do with it is you can code things with what's something like scratch code. You can connect different data types. It's very simple. They all have their descriptions in here. It's not that complicated once you look at it a little bit. But yeah, if you want to mess with the camera, change some things, you can just click on these and look at properties, see what they do. You can look at position distribution of your camera and actually change it. But right now we're focusing on creating our synthetic dataset. So for our synthetic dataset, we're going to go to synthetic data recorder, and we're going to add this camera to the data recorder. Choose your camera on stage, and then go back here, add new render product entry. And there it is. The path of your camera should be copied in here. You can click on your camera, and in property you will see your path, replicator camera, xform camera. If it's the same, it means it worked. For our data generation, we need to create annotated images, and the annotations are going to be bounding boxes. I'm going to make them tight, and I'm going to check that. And RGB means colored images, so I also want colored images. I'm going to check that. Then where I want my output to be, I'm gonna put it in my root just so it's easy to find. You guys can put it anywhere with this output. This is root, and then you put whatever path you want it to go to, and the name of the folder that you want it to be in. I'm gonna create number of frames means how many images are going to be created. I'm gonna only make 40 images, and I'm gonna press start. Perfect. Let's go look at our data set. Replicator 01. Here's the images that we just created from the Xbox controller. Again, you're going to see the images of whatever prim you were making images of. And then here are the bounding boxes. We have a .npy and .json file. The JSON file is the label of your item. For me, it's going to be 0 because that's the only thing being labeled. Class controller, that's what we labeled. In our npy file, it's going to be in binary, so a text editor won't be able to represent it. But if you open it and you see something like that, it means something was written on it. Now we want to convert this into YOLO V8 format for AI training, right? I'm gonna do a quick script to convert it, and I'm gonna put this on the GitHub link description, the GitHub on my GitHub, and it'll be the description of the video, the GitHub. Gonna go to the thing that we just made, and then I'm gonna go to the Replicator 01, and here's the conversion. Isaac to YOLO. Let's open another Isaac sim. Oh, what is that? Let's go back here. Python. Copy paste this, and then conversion completed. Dataset ready for YOLO V8 training at, and this is where it was copied to. Let's go look at it, see if it actually went there. YOLO dataset, images. These are our train values and our evaluation values. Perfect, they're all here. And make sure that they all have the same name as your labels, so YOLO V8 can connect them. Let's look at our YAML file, image train, image file, perfect. Now that we have that going, we can just train it with YOLO. And you will have your first AI model, or if you've done AI before, with Isaac Sim. This is the API call for YOLO V8 to train a model based on your data. YOLO detect train data. This is the path to my dataset. The data.yaml file is how it's gonna know what image and bounding box to look at, and then epochs and image size. These are for you can choose whatever you want in here. If you want to know more about these, look up what it means, and you can be more specific with your dataset. But this is basically how you would train a model with YOLO V8. Okay. Oh, I didn't activate my Anaconda environment. Oh yeah, and you have to download the YOLO V8 libraries for this to work. My libraries are downloaded in this environment, which is why it didn't work earlier. But if you just download it to your computer, it should work. And there we go. Now the AI is being trained by YOLO V8. Well, this is being trained. The library that you have to download for YOLO, it's called Ultralytics. You just do a pip install of Ultralytics for your Python, and it should get downloaded. It tells you once it's trained, it'll give you graphs of how the training and data loss. It'll give you a lot of graphs that will show you how your data was being trained. metrics. These are some ways of how to use it. Just look up Ultralytics and look at the documentation so you can understand better how to use YOLO V8. Here, this is the same thing I typed. Epochs 100, image size 640. Instead of scraping the internet for hundreds of pictures, we just did this really quickly. We were able to train our AI model. It's done training, and it says in here, results saved to Replicator 01 runs detect train. We're gonna go to runs detect train, and here it is. If you see something, if your graphs are labeled like this, it means that it trained properly. If your graphs just say stay at 0 and they have nothing, that means that something went wrong with it. Here it is. Bounding boxes of the Xbox created by themselves. How the AI learned to detect them. So the reason I did this was because I played too many video games and I have a camera looking at my controller at all times with my Raspberry Pi. With this model, I can now track how much time of the day my controller is there and not with me playing video games. And yeah, that's the magic of AI. You can automate processes by mimicking human critical thinking. The AI now knows if controller is there or not. Thanks for watching.